Hi everyone, my name is Shayna Swanson and I'm doing the oral report for experiment 13, or glowing reactions as I like to call it. The objective for this experiment is to see how concentration and temperature can affect the rate of reaction. Now, for the rate of reactions, the science of studying it is called kinetics. And there's one other factor mentioned in our lab manual that can affect us, and that is surface area. So let's get started with this experiment, shall we? For part one, you're going to use glow sticks. You want to open up the package that you got for your glow sticks. And just observe the glow stick, what color it is there anything inside the glow stick? Next, you want to activate the glow stick, noting the time. And after that, you want to go into a dark place, maybe outside as it's nighttime, or in a room with no windows, and see how bright it is. What can you see? What do you notice about the glow stick? Note all these observations, please. Next, you will stick it in cold water. What happens to the glow stick? Does the glow intensify or decrease? Next, stick it in warm water. Same question. After that, you're going to place it in a freezer for 24 hours. And check on it every so often. Try and place the glow stick somewhere where it won't get accidentally swiped out of the freezer by anybody, and where you can easily check on it. Mine had a little hook on it, so I just hooked it underneath the shelf on the side. And the main question for this is freezing it a good way to preserve the glow stick, or is there a better way, such as keeping it in warm water? The next part of this is dealing with concentration. You're going to label 3 cups, A, B, and C. First time through, you're going to crush a 1,000 milligram vitamin C pill and place it into a cup such as this. Add 60 milliliters of warm water and stir it. Don't worry if the solution is cloudy, this is okay. In cup B, you want to add 5 milliliters of your solution in cup A and 60 milliliters of warm water. Then add the titration of iodine, about 5 milliliters of it. What happens to the iodine here? Now in cup C, mix 60 milliliters of water, 15 milliliters of hydrogen peroxide, and half a teaspoon of cornstarch. How does the solution look to you? Now pour all of cup B into cup C and see what happens. Is there any sudden change, or does everything kind of mix together? Set it aside for right now and wait about 5 minutes. Wait 5 minutes or more to see if any reaction happens. Maybe you want to proceed with the second part of this part 2 and redo everything with a different concentration of vitamin C, and just keep an eye on your cup. Does the concentration of vitamin C affect how the I'm sorry. Hi everyone, my name is Shayna Swanson and I am doing the oral report for experiment 13. Hi everyone, my name is Shayna Swanson and I am doing the oral report for experiment 13, or glowing reactions as I like to call it. The objective for this experiment is to see how concentration and temperature can affect kinetics. Kinetics is the study of rate of reactions. Now, as you already know, since it's in this lab, concentration and temperature can affect this rate. However, another thing is surface area. Now, let's get started with this lab. For experiment 1, you are going to take a glow stick and take it out of the package and just look at it. What color it is? Does it have anything inside the tube? Just see what you can see. Noting the time, please break the glow stick, activating it. You should hear a small pop. Don't worry, you did not break it. After this, stick it in a cup of ice cold water. What happens to the glow stick? After that, stick it in a cup of warm water. What happens to the glow stick then? After that, stick it in the freezer for 24 hours. And occasionally just observe it. What happens to the glow? How long does it take for the glow to stop? Some question for this part of this lab is to See, what happens when you change the temperature of water that the glow stick is in? What happens when it gets stuck in the freezer? What happens after a couple hours? Does it glow still or is it done? And what happens when you take it out of the freezer? For part 2, you're going to need 3 cups, such as this, to label A, B, and C. You want to crush up for the first time through 1,000 milligram vitamin C pill and add 60 milliliters of warm water. Don't worry if the solution is a little cloudy when you mix it. This is okay. It's how it's supposed to be. In cup B, you want to put 5 milliliters of that solution with 60 milliliters of warm water. Add 5 milliliters of iodine. What happens to iodine when you add this? In cup C, you want to have 60 milliliters of warm water, 15 milliliters of hydrogen peroxide, and half a teaspoon of cornstarch. How does this solution look to you? Describe it a little bit. After you do that, mix cup B and C together, pouring them back and forth each time, making sure everything is mixed. Do you see any change right away? Set the cup down and wait until there is a change. How long does this take? What change do you see? And why is this change happening? For a second time through, pick a random amount of vitamin C to mix in. Something that will be easy for you to crush. I just doubled the vitamin C. You can do anything that you wanted to. Now let's get to some results for this. For part 1, my glow stick, when I stuck it in cold water, it started being really dimmed. It didn't shine as much, which is really weird since it was a camping glow stick, so it's one of those big old powerful ones that are really bright that you can use instead of a light bulb, it seems like sometimes. When I put it in warm water, however, it started glowing again. Now, some of this might be because of the change in temperature. When you put it in cold water, the molecules slow down and do not collide as much. That collision of molecules is what causes a reaction. So when I put it in the cold water and slowed the molecules, a reaction was happening slowly, so it wouldn't glow as fast. However, when I put it in warm water, it sped up the reaction again and made the reaction faster, and so it glowed brighter. In the freezer, it took about 2 hours for the glow to completely go out. When I took it out, it took about 20 minutes to defrost, give or take 10 minutes, and it started glowing again. I think this is the best way to preserve a glow stick. If you can just put it in the freezer when you don't need it and then take it out when your kids need it, great, then they can have glow sticks and you can save some money when they're running around with their friends. However, the glow stick will not last forever. Like all things, nothing lasts forever. And for part 2, when I made cup C, it looked like milk to me, basically. Like whole milk. It did not have any water in it. It just looked really white and creamy. When I added cup B to cup C, there was no instant reaction. I poured them 3 or 4 times and I set the cup down. At first, it only was black on the bottom. I believe this is because of concentration of vitamin C. Vitamin C is acidic, while iodine is basic. So they are not mixing with each other at first. However, within time, especially with the 2,000 milligrams, they mix, and causing what you see here. So, to finish this experiment up, do you think there's any real-world applications for the second part of this, or even the first part of this? Do you know some real-world examples that you personally do, or you know that anybody else does? Thank you for listening to my oral report. I hope you have enjoyed it and it has been informational for you. If you have any questions, don't hesitate to ask.